All right. Okay, so let's get started. So this is a mini project for cs438. My representation topic is BGP routing policies in ISP networks. My name is Nguyen Fan, and here's my net ID. So firstly, this will be the outline of my presentation. I will firstly brief talk about the BGP, and then I will talk about 3 steps of the BGP routing. I will talk about import policy and export policy together. Then I will talk about their relationship with decision process. And then I'm going to talk about 4 general categories of the BGP routing policies: the business relationship policy, the traffic engineering policy, the scalability policy, and also the security related policy. And lastly is a reference part. So a BGP protocol, now that we've taken the cs438, it's just used to determine the optimal path between different autonomous systems. So autonomous system basically mean a subnet of devices, which contains hosts, PCs, and routers. So as you can see here, we have 2 possible routes, the green route and the red route. So the BGP protocol will be running on the gateway router. It will decide the proper routes to forward the packet. And next, so this is more details about the BGP protocol. It will be running on the TCP protocol on the port 179. So once there is a BGP session between 2 routers, they will exchange incremental updates to share the routing information. And then let's talk about the policy with BGP. There are basically 2 types of policies, the import policy and the export policies. So the import policy will decide what to do with the routes learned from the neighbors. And the export policy will, of course, naturally, it will decide what to do with the routes that I generate. What kind of information should I share from my neighbors? Should I share them with all the routing table, or just part of the routing table? So that's the responsibility of the expert policy. And next, let's look at how the import-export policy works with the route decision process. So here, let's see, pointer options. Right. So here is import policy. Here is export policy. And in the middle, we will run our routing algorithms and we will generate the forward table. Okay. So we receive a BGP updates. We apply the import policy. So we maybe it's just some filter. So we'll filter out some malicious routing information. We will just only keep the useful information, and we will run the routing algorithms. We will make some route selections. Then we generate the forwarding table, and then we apply the expert policy to decide what kind of information we're going to share, what we are going to transmit to our neighbors. Okay. So let's look at the next slides. So here is a few factors that is going to decide which route we chose. We are going to talk a bit more in the traffic engineering policy part. But here are some factors. And this arrow means the priority is from high to low. So the highest priority factor is a local preference. The lowest one is a router ID. So the router ID is only used when all the above factors have a tie, and we have to, break the tie. So the lowest router ID is basically a tiebreaker. So this AS pass means autonomous system pass. This MED, we will talk about it later. It's used to decide a pass when there are multiple possible candidates between two autonomous systems. Okay, so this IBGP, EBGP means whether this routes is learned from the internal BGP protocol or the external BGP protocol. Okay. Okay, so right now we can finally talk about the real policy part. So the first policy we're going to talk about is business relationship policies. So before we get started, so let's refresh with some business relationship that we might have in a network. Okay. So the first kind is customer and provider type. So let's suppose you are a server and I am a host. I am a personal computer. So I'm a customer and you're a provider. So whenever I search something on Google, the Google will send back the result to you. And you will send the HTTP file back to me, right? So whenever there is a traffic between you and me, it means that you are providing me something because you are a provider. So in that case, whenever there is traffic between you and me, I need to pay you some money, right? Because you are a provider and I'm a customer. So naturally, the provider wants the traffic as much as possible because they want to make money, right? So now let's look at another relationship, the peering relationship. So the peering relationship means two autonomous systems, they are equal. Like I'm not a customer, I'm neither a customer nor a provider, and you are also neither a customer nor provider. If we have a similar size traffic in between, then we are possibly a peering relationship. I'm not going to charge you money, you're not going to charge my money, and we can send the package freely between you and me, right? So here is a diagram. So A, B, and C, there are three customers, and they also have corresponding provider. So those three providers are peer relationship to each other. Okay. So now let's suppose A requests some information and it need to be sent from here. So it will first send to this router, then this router, then send from the provider to A, right? So A need to pay money to A's provider, but it won't pay money to this router and this router. Why? Because it didn't get the packet from those two routers directly. It get the packet directly from its provider. And the provider of A are peer relationship to those routers. So the provider of A also doesn't pay money to those two routers. Okay, so let's move on. So how can this business relationship come into play? Two possible influence. It can firstly influence decision process. Why? So an autonomous system would prefer customer learned routes over the peers and providers and backups. Why? Because whenever there's path traffic coming from the customer learned routes, the customer needs to pay you some money, right? If some traffic coming from the provider learned routes, then I am a customer. I have to pay money to the provider. That's not what I want, right? And another possible influence is that it can, okay, let me use a pointer. It can influence the expert policy. So the routes learned from the providers or peers are usually not exported to other providers. Means I'm not going to further forward that information away. Why? Because I can't make money from it. So when I export that information to other autonomous systems, I'm not going to earn money from that, right? Only the provider will make money, and I'm not the provider. I only give you the forwarding, the routing information, right? So that's two possible influence. And let's move on. And then the traffic engineering policies. As we talked about, there are a few factors that can affect the routes we take. So let's explain this MED further. This AS means Autonomous System Pass and Local Preference, Next Hope. The MED might be a little bit unfamiliar to you, so I will explain it. It's multi-exit discriminator. It is used when two autonomous systems, they're connecting to each other with numerous possible paths. So here is an AS. Here is another AS. If they are connected with different possible paths, I have to make a decision on which one I should pick, right? That is when MED comes to play, okay? So let's move on. So for the traffic engineering policies, there are two things we need to consider. The first thing is outbound traffic control. For outbound traffic control, there are two types. The first type is early exit routing, means we are always trying to send out a package at lowest cost as possible. But that can bring us a problem. So if there is a destination and it requires a lot of packets, then I'm going to forward a lot of package out, which will basically congest the same link, right? Because every packet is following the same link, so it will congest it. So naturally, we will think about doing load balancing, right? When there is a huge traffic, we're going to spread it across different possible paths to the destination, right? And also the inbound traffic control. Let's suppose you have an internal link and it's already congested. In that case, I don't want the external traffic to continue go on that link, right? But the external traffic has no idea of the internal traffic conditions. Why? Because of privacy reason. So that's not some information I possibly going to share with the external routers. So in that case, I have to change the MED to tell the autonomous system, okay, you need to change a new route. This route is very heavily trafficked. So you better send it to another routes to alleviate the traffic congestion, right? So let's move on. The scalability policy, it means when a network becomes larger and larger, it can be disaster. Why? There will be excessive advertisements of traffic control message, which will basically congest your link. So it will overload the router CPU or memory, because some small ISP, they use very poor routers, you know. So how do we solve that? Two possible ways. First, we can limit the size of our routing table. Remember, in a routing table, an entry is a prefix of a destination and interface we're going to forward it, right? So the first thing we can do is to do the aggregation on the routing table. So if they're all going to the same subnet, it may not be the same destination, but if they go to the same subnet, which means they have the same common prefix, then we can do the aggregation. Or if the prefix is too long and we cannot run aggregation, we might simply drop that entry. A second possible way is to suppress the routes that flap frequently. If a cost of a link changes again and again, we can set a threshold to record the times that it has changed. If it exceeds the threshold, then we can add a penalty to that link, or maybe we just abandon that link, right? So that's for scalability. Then finally, let's talk about security. So why BGP has security problem? Okay, we're running out of time, so I will be fast a little bit. So there are a few reasons. The first reason is that you might receive false routing information, right? If a device or a router is hijacked, it can send out false routing information to mislead you, right? Another possible reason is that your competitor, they want to deceive you. So they want you to send packets at a higher cost, or they want you to send the packet via their network so they can charge you, right? So how can we deal with that? So first thing we can do is to discard invalid routes, right? So if there is an invalid route or we know it's a malicious routing entry, we simply drop it. Another way is to use export policy control, which means if you have a server or if you have a router that runs valuable assets, then you want to keep it secret. You don't want external devices to see this server, right? You want to make it invisible. So you will run the expert policy and you will just filter out that information. So that way your privacy can be protected, right? And finally, if there is possible denial of service attacker, you can drop all the routing information from that defender, that attacker, right? Okay, so that's so much for the BGP. And here is a reference, and thank you so much for listening. See you.